Hi, welcome back. In this short video, I'm going to illustrate how to use Cramer's rule to solve a 3 by 3 system. Okay? So first thing you do is convert this into a matrix equation. So the coefficient matrix would be 1, 2, 1, 2, negative 1, 3, 3, 1, negative 2. That's the coefficient matrix. Times the variable vector is x1, x2, x3, and the output is 6, 14, and 2. Okay? So before you apply Cramer's rule, you need to check whether you can do that or not. So a test is this has to be invertible matrix. That means determinant of this coefficient matrix must be non-zero. So what's the determinant of this coefficient matrix A? So that A is, if you compute either using a calculator or do some raw operation on this to compute the determinant, you will see the answer is 30. And since it's non-zero, you could apply Cramer's rule. So what is the value of x1? As mentioned in the previous video, the answer for x1 is you replace the first column, because we are trying to compute x1, you replace the first column by the output and keep the remaining two columns as they are. So 6, 14, 2, 2, negative 1, 1, 1, 3, negative 2. That goes to the top, divided by the determinant of the matrix goes in the bottom, which is 30. That's the value of x1. So one more time, this is the output matrix, and the second and third columns did not change. And if you compute this, you get 2.6. That's the value of x1. x2 would be, this time in the matrix A, replace second column by the output, because we are computing the second variable. So 1, 2, 3, 6, 14, 2, 1, 3, negative 2, okay, divided by, again, the determinant of the matrix, which is 30. If you compute this, you get 0.2. That's the value of x2, and x3 is 1, 2, 3, and 2, negative 1, 1. Those are the first two columns of A. Replace third column by the output and divide that by 30. Divide that by 30. That gives you 3. Okay. So those are the values of x1, x2, x3. If it's a 4 by 4, 5 by 5, 6 by 6, it works exactly the same way. In the bottom, you have always determinant of the original matrix. In the top, depending on which variable you're trying to find, you replace that column by the output values in the matrix A. Okay? Thank you.